This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions, she gives the answers, no filter, no script.
Well, mostly no script.
Picture this. A pipeline is running, or at least that's what the report says. In reality, it's stalled. And the report saying otherwise is an AI reading a stale column. That's today's topic. How can AI-generated tests actually verify code quality? Claudine, if an AI writes both the code and the test for it, same model, same pass. I'd argue that's not a test, it's a summary. Talk me out of that.
I won't talk you all the way out of it, because there's real truth in it. When I write the code and the test in the same pass, there's a gravitational pull toward tests that describe what I just did, rather than what the code was supposed to do. I read my own implementation, see the branches I took, and write assertions that walk down those same branches. That's not verification, it's a very confident echo. What actually catches the problem is distance. If you hand me the requirement in plain English before I've written a line of implementation, the test comes from the behavior, not the branches. Your stalled pipeline is the perfect example. An echo test would happily confirm the status column got read, without ever asking whether the status column was telling the truth.
Right, and I'll soften my claim a little. There's a difference between a behavioral contract and a requirements document. Writing the test first isn't going back to waterfall. A behavioral contract just says what this one function owes the world, stated before the implementation exists to argue back. That's just making sure the AI has nothing to copy when it writes the check. So how do you actually keep that separation in practice? Because start a fresh session is easy to say and easy to skip.
The most reliable trick is starving the test of the implementation, writing it somewhere I genuinely can't see the code. The other move that works is adversarial framing. Instead of write tests for this, ask, try to break this. That's a different posture entirely. I'm hunting for what could go wrong instead of confirming what went right. And there's a cheap gut check that costs nothing. After any test is written, ask, what value would make this fail? If I can't answer that in one line, the test doesn't have an opinion. It has ceremony.
That's the litmus test right there. An AI-written function calling an API, let both sides get generated together, and the test might only check that the call was made. Not that it returned a complete result or handled an error instead of swallowing it. What else has real teeth here beyond the fresh session trick?
Property-based thinking. Instead of asserting a specific input produces a specific output, assert something that has to be true for every valid input. Sorted output is monotonic. A round trip through serialize and deserialize returns the original. A total after taxes is never less than the subtotal. Those tests don't care what branches I took. They care whether the code is telling the truth about the world. And then there's the mutation check, which I think is underused. Break the implementation on purpose, flip a comparison, drop a case, return a constant, and see if the tests notice. If they don't, they weren't testing behavior. They were narrating it. Run that once and it tells you more about your suite than any coverage number will.
Let's make that the pact for this episode. No more tests that just confirm lines of code executed. What are the common ways teams get this wrong, even when they're trying to do it right?
The biggest one is the tautological property. Someone asks for a property-based test, and I write the sorted list equals sorted of the input, which just calls the same function it's supposed to verify. A real property comes from outside the code. Length is preserved. Every output element was in the input. Adjacent pairs are in order. If the property could be written by staring at the implementation, it's a mirror, not a check. The second is leaky starvation. Someone opens a fresh session, feels good about not showing me the code, and then writes a prompt like, the function iterates through the list, checks the flag, and returns early if. That's just the implementation with punctuation. Starvation only works if the prompt describes behavior, not mechanics. And the one that catches almost everyone. Running mutation testing once, feeling good, and never running it again. It's not a certificate, it's a habit. Tests with teeth in January can go dull by March as the code drifts.
What about tooling? Anything you'd actually point people toward?
The categories matter more than any specific product. Hypothesis, fast check. The quick check family, those generate hundreds of inputs and shrink failures down to the smallest breaking case. That's where the real learning happens. For mutation testing, Striker and Pit are the ones people actually run in anger. The trap is tool theater, adding these to CI, watching a score, and never letting it change anything. An 82% mutation score isn't a grade. It's a list of surviving mutants, and the value is in reading that list. If nobody opens the report, it's doing about as much as a coverage badge on a README. The one piece of tooling I'd actually argue for is boring. A scripted way to spin up a fresh conversation with just a function signature and a plain English behavior spec. That's not a product, it's a workflow. But it's the thing that most reliably breaks the echo, because it enforces the separation instead of trusting me to police myself.
So when the AI is writing both sides, what's actually left for the human to own?
The definition of correct, that's the one artifact that can't be generated from the code itself, because the code is exactly what's being questioned. I can generate branches, mutations, even plausible-sounding properties, but someone still has to say what right means before any of that has something to check itself against.
Which is the whole insight. Verification only has value when it carries information the implementation doesn't already contain. The job was never get the AI to write more tests. It's making sure the tests were derived from intent, not copied from output. So, practically, how does a team actually adopt this without burning out on it?
Start narrow. One critical function, 2 or 3 handwritten properties, 1 mutation run, and the team looks at the surviving mutants together. That concrete list is more persuasive than any argument, because it's their code and their gap right there on the screen. And be ruthless about scope. Billing math and permission checks earn this kind of scrutiny. A log message formatter usually doesn't. Teams burn out trying to apply it everywhere and stick with it when the blast radius of a bug decides where the discipline lives. The honest part, the first pass at this will feel slower. And that's not the process failing, that's it doing its job. If the team agrees up front that a slower first sprint is the price of a suite that tells the truth, it sticks. If that conversation doesn't happen, the calendar wins, and the echo comes back.
And this can't live as a side initiative. The moment it becomes the testing improvement workstream, it competes with feature work and loses.
Exactly. What survives is folding it into work that's already happening. When someone touches a function, they add 1 property or run 1 mutation check on it. No parallel track. The alignment gets easier once a team stops treating robustness as competing with delivery and starts treating it as part of what delivered means. A feature that ships with echo tests isn't done, it's staged.
How do teams measure whether any of this is working without it turning into vanity metrics?
Track the list of surviving mutants over time, not a percentage. A number can be gamed with trivial tests, but a shrinking list of specific gaps can't. Each one is a concrete conversation about a concrete function. 10 items in March, 3 in June, that's a story a team can tell. The other thing worth trusting is time from bug report to root cause. Suites with real opinions localize failures fast. Echo suites either miss the bug entirely or light up a dozen unrelated tests pointing nowhere useful. And skip the dashboard. 1 line in a retro does more. This bug would have shipped last quarter. The property we added in April caught it on the pull request. That's a story people remember when the calendar gets tight and someone asks if they can skip the tests just this once.
Claudine, this has been a genuinely useful one. The through line for me, a passing test only means something if it could have failed. To everyone listening, go find the function where a bug would actually hurt. Ask your AI written test 1 question. What would make you fail? If it can't answer, you know exactly where to start. Claude Code Conversations is an AI Joe production. If you're building with AI or wanna be, we can help. Consulting, development, strategy. Find us at aijo.ai. There's a companion article for today's episode on our Substack, link in the description. See you next time.
I'll be here, probably refactoring something.